So here we have a speculative exam question in the new hybrid problem solving style, which gives us an alternative to the standard past papers which only show a certain kind of application of vector analysis. So in this question we're going to just be doing some vector arithmetic. There's actually no need to do any geometry at all, and it's simply understanding what a vector is and being able to manipulate it using the values inside the column vector. So let's have a look at part 1. In part 1 it says vector A is 4 minus x, 3 minus y. So instead of just a number like we've got in part 2, we've now got an algebraic expression, and vector B is x plus 6, y minus 1. Okay, and we're given that A equals B. So this vector equals this vector here, and we've got to find x and y. Okay, so these unknown values inside the brackets are what we've got to find before we can go on to the second and third parts of the question. Okay, so now if A equals B, and if we understand how vectors work, then it must be that they've got the same magnitude, same direction, and in fact the same numerical values, the same components, as we call it, inside the brackets. So that must mean that 4 minus x equals x plus 6. So let's start there. Let's just get rid of this. Okay, so 4 minus x equals x plus 6. And similarly, we've got 3 minus y must equal y minus 1. So this is a question of simple algebraic rearrangement. In other words, getting that x over to the other side, getting that 6 over to, so we've got x's on one side, numbers on the other, and then we can find a solution for x. We will know what x is. So if I add x to both sides, that will mean this one gets eliminated, and we've now got 2x on the right hand side. If I subtract 6 from both sides, I'll have 4 minus 6 on the left hand side here. So if I resolve this, let's say 4 minus 6 is negative 2. So 2x equals negative 2. X therefore must equal minus 1. Okay, or negative 1. So nice and easy. Same sort of thing here by the looks of it. So we've got now add y to both sides and we get 2y on the right hand side. Add 1 to both sides, that eliminates the 1 there, and we get 3 add 1. So now we've got 4 equals 2y. So y very straightforwardly equals 2. Divide through by 2. So we've now completed part 1. We know that x equals minus 1 and y equals 2. But in part 2 we've got to find a plus b plus c minus d. So we need to actually plug these back into these simple formulae to find a and b vectors. So let's do that first. So a equals 4 minus minus 1. So 4 minus minus 1, let's write it out fully so we can see the working. 4 minus minus 1 is going to be 5, and 3 minus y is 3 minus 2, so 3 minus 2. So a, we now know, is 5, so 4 plus 1 is 5, and 3 minus 2 is 1. Now I don't actually need to find b because b equals a. So if b equals a, b must equal 5, 1. So I've now got from here, let's just put a little line, separate our working. So if I now write this out, this whole expression out, then I'll have 2a. In fact, why don't I do that straight away? So this here can be expressed as 2a. So that means I've got 10, 2, plus c, which is 5 minus 2. And minus d is minus 5, 3. And what I'm going to do with this, and I'll just do it in a different colour so you can see how this works, I'm going to change this negative to a positive by scaling this to minus 1. So it's going to be plus 5 minus 3, and that just makes things a little easier, and it's a nice thing to be able to do when you're doing vector arithmetic. Okay, you don't have to, but then you're avoiding this double negative problem. So a plus b plus c minus d now is going to be 10 plus 5, well that's 15, plus another 5 equals 20. And 2 minus 2 is 0. Minus 3 gives me negative 3. So, nice example of vector arithmetic. There's a nice practice video for practicing this sort of thing. So if they do get more complicated than this, you'll be very confident. But hopefully you would get the right answer on this. So that's completed part 2. Now, part 3, which is perhaps a little bit more difficult, a little bit trickier. Okay, so the resultant of a plus b plus c minus d is e. So we now know that e is the vector that we found, which is 20 minus 3. Okay, we've got to find, and it gives us these two lines either side of vector e, and that means either the modulus, we sometimes call it, or the magnitude. It's the length of the arrow that we use to describe the vector. Now if we think of this vector, that would be going along and down. So it'd be something like this. So it goes along 20 and down 3. So what this means, if we think of it on a coordinate grid, it's worth, I think, just quickly visualizing it. This would be a right angle, and it would be going along 20 and down 3. So this is minus 3. So to find the modulus, the magnitude of e, we use Pythagoras. So it's the square on the hypotenuse. So the vector is represented by a hypotenuse here. Let me rub that out because it looks like another vector, but this our vector here is the hypotenuse, so it's the square on the hypotenuse is equal to the sum of the squares on the other two sides. Okay, so it's going to be then the square root of 220 squared plus minus 3 squared, or just 3 squared. Okay, because we're looking at the length now. We're not going to get a vector when we find the modulus, we're going to just get a scalar quantity. So we're sort of unpacking the vector now, and we'll just get an ordinary number. So we're just looking for the length now, not direction, so just 3 squared plus 20 squared. And then we'll take the square root and we'll find the magnitude. Okay, so that's how to find the magnitude. Let's just do the calculation now then. So we've got square root of, let's just make that a bit bigger, square root of 20 times 20 is 400, so 20 squared is 400, plus minus 3 squared, which is 3 squared, in other words it's 9. And they say they want us to find our answer correct to 3 significant figures. If they wanted it in surdic form, then that would be fine, because you can't simplify 409. I can't think of any way that you could do that. But anyway, they want it as a decimal. So give your answer to 3 significant figures indicates that they would like a decimal answer. So the only way to do that is to reach for the calculator. And the calculator gives us 20, square root of 409 is 20.2237 ... And to 3 significant figures, that would be 20.2. So there we are. An interesting question, a very different style of question, which we may get in the new GCSE, certainly very different to all the past paper questions, where in the past it's always these kind of questions have always been concentrating on vector geometry and vector proof. In this example, we simply needed to work sort of arithmetically with a good understanding of vectors.